about the program. இல்ல அவர் வேணாம், அவருக்கு வெல்கம் அட்ரஸ் கொடுக்கணும்.
ஓகே சார்.
அது சப்ஜெக்ட் தெரிஞ்சவங்க தான் அது கொஞ்சம் நல்லா பண்ண முடியாது. அவரு ஜென்ரலா வந்து இப்போ இந்த ப்ரோக்ராம் எதுக்கு நடத்துறோம்ன்றது எந்தாவது ஒரு இடத்துல நம்ம சொல்ற மாதிரி இருக்கா? ஜென்ரலா சொல்லுவாரு, இன்னைக்கு ஒன் டே ஒர்க் ஷாப்
சார் ஹெச்ஓடி சாருக்கு சொல்லியிருக்கோம் இந்த மாதிரி இந்த காம்படிஷனை பேஸ் பண்ணி நடத்த போறோம் அப்படின்றதால. ஸோ அவர் அதை மென்ஷன் பண்ணி பேசுவார் சார், அதை இண்டிகேட் பண்ணுவாரு.
இல்ல அது இண்டிகேட் பண்றது நீங்க வந்து அந்த போர்ஷன் வந்து அவர் கவர் பண்ணணும். அவர் யூஸ்ஃபுல்லா பண்ற வெல்கம் அட்ரஸ் அவர் பண்ணிட்டோம்.
சரிங்க சார்.
இது வந்து நான் பண்ணிடுறேன், காம்படிஷன் பத்தி நான் சொல்லிடுறேன்.
ஓகே ஓகே சார்.
அது நீங்க vote of thanks வந்து நீங்க சொல்லிடுங்க, அந்த சேஞ்ச் மட்டும் பண்ணிடுங்க. ஸ்வாதி.
சரிங்க.
ஸ்வாதி இருக்காங்களா?
சொல்லுங்க சார். இருக்கேன் சார்.
இன்னைக்கு ப்ரோக்ராம்ல இந்த அபவுட் த ப்ரோக்ராம்னு ஒன்று ஸ்டார்ட் பண்ணிடுங்க. ஃபர்ஸ்ட் இவரு ப்ரெசென்ட் பண்ண பிறகு ஹெச்ஓடி வெல்கம் அட்ரஸ் கொடுத்த பிறகு அபவுட் த ப்ரோக்ராம்னு ஒன்று சொல்லிடுங்க.
ஓகே சார்.
அதுல வந்து நான் வந்து அபவுட் த ப்ரோக்ராம் கொடுத்துட்றேன். vote of thanks கால் இருந்தது இல்ல, அது வந்து ஒரு டெலிவரி சார்ட்ட கொடுத்துருங்க.
ஓகே சார்.
ப்ரோக்ராம் பத்தி அது நம்ம யாராவது ஒருத்தவங்க எக்ஸ்பிளைன் நல்லா இருக்கும். இப்போ ஆக்சுவலா இவங்க எல்லாம் பேசுறாங்கல்ல, பிரின்சிபால் எல்லாம் பேசுறாங்களா, அவங்க என்ன நினைச்சுப்பாங்கன்னா இது ஒரு ஒன் டே ஒர்க் ஷாப் நினைச்சிட்டு இருப்பாங்க, ஸ்டூடெண்ட் ட்ரைனிங் ப்ரோக்ராம் நினைச்சிட்டு இருப்பாங்க. பட் ஆக்சுவலா இது நம்ம காம்படிஷனுக்காக ட்ரைனிங் கொடுக்குறோம். சரியா? கரெக்டா ஹைலைட் பண்ணோம். அது வந்து நான் பண்ணதான் நல்லா இருக்கும். ஓகேவா?
ஓகே சார். அப்போ ஃபர்ஸ்ட் வந்து ஒரு ஷார்ட் வெல்கம் நோட் கொடுத்துட்டு அடுத்து தமிழ் தாய் வாழ்த்து சொல்லிட்டு அடுத்து ஹச்ஓடி சார் வந்து வெல்கம் அட்ரஸ் கொடுத்ததுக்கு அப்புறம் நீங்க வந்து
12 initiative of Israel focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age.
Surajidhan sir, good morning. Hello.
Sir, good morning, sir.
Good morning sir. Sir, our sir join பண்ணிட்டு வரீங்களா?
Yes, sir. I informed him he will join shortly.
Shortly. Okay, sir.
Yeah.
Morning, Anthony.
Good morning sir. Good morning sir.
Good morning, I joined.
சார் ஸ்டார்ட் பண்ணலாங்களா சார்? சார் வந்துட்டாருன்னு நினைக்கிறேன். அவரு சார் வந்துட்டாரு. சீஃப் கெஸ்ட் வந்துட்டாருன்னு நினைக்கிறேன்.
நீங்க எப்படி ப்ரொசீட் பண்ணுமோ பண்ணுங்க. நீங்க ஹெச்ஓடி எல்லாம் வந்துட்டாங்களா? பிரின்சிபால் வந்துட்டாங்களா?
சார் வணக்கம் சார்.
சார் வணக்கம் சார்.
சார் குட் மார்னிங் சார். குணசேகரன் சார் குட் மார்னிங்.
குட் மார்னிங் சார்.
Sir, sir is the chief guest. Our HOD is also there, sir.
Good morning. Sir, welcome, sir.
Yeah, VP is also there. Good morning, sir.
Good morning, sir. Welcome.
I think VP admin has to join. So I think we can start now, sir. அவர் வந்துட்டாருங்களா? VP admin ஆனந்த்குமார் சார் வந்துட்டாரு இல்லைங்களா? ஓகே. Ganesh, shall we start?
Sir, yes, sir. We can start. Our side, everyone is present here.
Okay.
Yes, sir. Yeah, we can start.
HOD sir. HOD sir.
Yes, sir. Start பண்ணிடலாம் சார். Yes, sir. சொல்லுங்க சார்.
VP admin இல்லைங்க சார். VP
ஸ்டார்ட் பண்ணிடலாமா?
அதான் சார் VP
admin டவுட் தான் சார். முடிஞ்சா வந்துறேன்னாரு. பட் நம்மள ஸ்டார்ட் பண்ண சொல்லிட்டாரு. பேசிட்டேன் சார்.
ஓகே. ஓகேங்க சார். ஓகே சார். Then we will start, sir. Swati?
Yes, sir.
If you can start.
Good morning. On behalf of History Student Chapter of Ishwari Engineering College, I extend my warm welcome to everyone for the one-day workshop on air conditioning systems for an IT company for better indoor air quality. I hope that all are safe and healthy in this pandemic period by practicing social distancing and hygienic habits. Now, let us start this event with a devotional note, Tamil Thai Valthu. Now, I request Head of Mechanical Department of Ishwar Engineering College to welcome the gathering.
So, vanakkam and happy morning to one and all. It's a pleasure to be in your midst today of History Chennai chapter, conducting the Ishwari unit, conducting the one-day workshop today. So, I welcome Mr. Guna sir of Innoval International for the Innoval Engineering International for this program as the chief guest. Thank you, sir, for accepting our invitation, and your gracious presence is going to motivate us to do better programs and more programs like this to motivate our children and all the student community and faculty. So thank you, sir, for accepting our invitation and joining us this day. And I extend my warm welcome to all the office bearers of the History Chennai chapter, including Dr. Anthony. And next, I would like to thank our for joining us this day, and he has been a pillar of support for all our events. He has for his blessings and support for all the events, sir. Welcome to you, sir. Next, I would like to welcome our VP Admin and VP Academics, sir. Ilango sir, who is also a professor in the Department of Mechanical Engineering. Thank you for your unflinching support and advice for all our events, sir. Thank you and welcome for this function, sir. Next, I would like to welcome all my colleagues and the History Student Chapter office bearers, Shashwat Khanna, Vishnu Priya, and all the office bearers for and Ganesh also. So for the wonderful event. So thank you, and I hope it's a wonderful day of learning for all the participants. So welcome participants and have a great day. Stay safe and healthy. God bless you all. Thank you. Have a nice day.
Thank you, sir. Now, I request Dr. V. Anthony Arulraj, Student Activities Chair, History South Zone, to speak about this workshop.
Good morning to everyone. It is indeed a happy moment to be a part of this program. Basically, this program, it is being conducted for training the students for National Student Design Competition 2021. So, which is conducted by ISRE, okay, Indian Society of Heating, Refrigeration and Air Conditioning Engineering. So, the theme of the design competition, NSDC competition, is design of air conditioning system for an IT company for better indoor quality. So the first prize for this event, it is going to be 30,000. The second prize is going to be 20,000, and there are going to be several motivational prizes for rupees 10,000. Okay, so the jury members are going to be top-notch industry experts across the country. Theme of the so phase 1, we are going to have the registration on 19th of August 2020, and the submission of design is going to be on 31st of October, and the design presentation at the zonal level, we are going to have it on 28th of November, and the design presentation at national level, it is going to be on 30th of January 2021. Okay, so it is going to happen in a phased manner. So what is the theme? What is the theme of this? So we have to do a HVAC system selection and the design of an IT company with the following major decision rules. So designing a complete energy efficient HVAC system with all important subsystem, assuring better indoor air quality, measuring undertaken to address human comfort and take care of foul air to avoid suffocation, optimizing the fresher loads by maintaining appropriate ADP bypass factor, which directly affects on the energy efficiency of the system. And we have several rules. Okay, so there should be the students should be the undergraduate students. There should be maximum of 4 students per team, and there should be a mentor, and the design should be as per the Indian standards. So these are the things which are. So what are all the aspects which is expected? Okay, so the proposed system details of an IT company system design with the necessary drawings that has to be submitted. Design basis report with assumptions, energy calculations, duct designs, etc. Specific assumptions has to be listed. HVAC and IEC. IEC means International Electrotechnical Commission System. selection based on energy efficiency and other features to be submitted. Airflow design and distribution, part load efficiencies and life cycle analysis. Any comparison between VRF and chilled water system, and health safety features and standard follow-ups, and the energy balance sheets with the loss and savings, and the detailed drawings of all the subsystems has to be submitted. So this includes, okay, so that requires knowledge on heat load calculation, equipment selection, duct design, originality, there should be innovation, there should be design of all fluctuating loads, and energy calculations and affordability. So when this NSDC plan was floated, so there was a request from the students and the student chairs for conducting a program, so that the students will be able to do all these calculations. Okay, so based on the request, this program was organized. So we thought that if instead of faculty members doing that, the industrial experts who already do this calculations on day-to-day basis, if they do that, so it will be most helpful for the students. So on that basis, so we have organized this program. I think this program will be more useful for the students for participating in the NSDC competition. So my thing is, so more than the competition, learning the concept is very, very important. So the learning of the concept, okay, so we will be receiving the prize, whatever may be the prize amount. So that is one aspect. But when we are competitions like this, so students will be having the experience of designing a HVAC system, and that will be useful for them if are pursuing their future future in the industry. So that will be more useful than the competition. Okay, so for that purpose only we have arranged this program. Okay, so and with this overview of what is NSDC and how this program is organized, so I wish the best for all the students. I want the students from the South India, so that is from my zone, so, South India, to win the NSDC competition. So that is my ambition or intention. So hope this program will help the students for winning the competition. Thank you.
Thank you, sir. I request Principal of Ishwari Engineering College to share a few words.
Good morning, everybody, and Bakrid wishes for all our Muslim friends in this meeting today. This is an amazing event. I want to first congratulate and thank ISRE for giving us this umbrella event. And we have got a practicing HVAC engineer, Mr. R. Gunasekar Raju. Thank you, sir. I joined with our HOD and our Professor Dr. Anthony in cordially welcoming you and thanking you for handling this workshop. NSDC will definitely make a very big difference in any student's life. Participation will make very big changes. Winning will create such a big change in their life. I'm so happy. When I was a student, I won NSDC. That was for a garbage collection system. And it made a very big difference that how we design, how we prepare the drawings, how we prepare the calculation, the analysis, everything. I think it will give a very cumulative positive effect on the student as well as the guiding faculty. Mechanical engineering department of Ishwari is doing so many positive activities, and it is beneficial for the students as a whole, for our college as well as for students of other colleges. Starting Monday, we are also training 10 different other colleges, more about 150 faculty on getting accreditation through NBA. This is another very big activity sponsored by AICT and Margadarshan scheme. We are doing this activity. As far as ISRE is concerned, when we could see the opening presentation on ISRE, it is such a beautiful area. There is so many opportunities available. I hope our students take full use of it. I think there are students from other institutions also from the South Zone in this. So please take the fullest use so that you will win in your career. That is most important. Yeah, and mechanical engineering department is providing the necessary platform for all of you to achieve. That is a great thing by the HOD, Dr. Anthony, and his team of people, my colleagues, both VPs, Dr. Ilango and Dr. Ananda Kumar, who are here to guide them, support them, and take all the necessary activities on their shoulders so that the entire event becomes a big success. Ishwari is an autonomous institution. From last year, we are autonomous. Some institutions have opted for only 1 year of autonomous conduction. We have opted for all the 4 years of autonomous conduction. So the exams for the last year, that is second year, third year, fourth year, we conducted. And this year it will be for the third and the fourth year. So all 4 years are under autonomous, and happy to note that the positive messages, the positive information, the positive references from the students and the faculty have gone out, and we could see all seats in mechanical filled up, all seats in the college filled up. We do have few lateral entry, so I request anybody interested to please approach me or HOD Mechanical for the lateral entry seats. Okay, there are so many activities that we are doing differently. That is around 60 odd activities we are doing differently, which has enabled the students to achieve more in their life. So saying, I wish this function, this workshop, a very big success, so that final beneficiary are the students. After the students, it will be their families. Then from the families, benefit will trickle down to the various industries and to the society at large. Thank you so much, sir. Guna sir, once again, I want to thank you. And I also want to thank the many participants for being here. Best wishes. Have a great day ahead. Jai Hind.
Thank you, sir. Now, I request Vice Principal Academics of Ishwari Engineering College to share a few words.
Good morning, everyone. Hello, is it audible? Hello.
Yes, sir. It is audible, sir.
Okay. Good morning. Respected chief guest for this day, Mr. Guna, Managing Director of Innoval Engineering International Limited. Respected principal, my colleagues, our VP admin and HOD Mechanical, and Dr. Anthony and Dr. Dilip Babu and other colleagues. I'm extremely happy to be in front of you to say a few words about the department as well as this Ishwari chapter of our college. Before that, I want to thank Mr. Guna for accepting our request to be as chief guest of this day. I know that Innoval Engineering International Limited has supported our Ishwari chapter many times, and they have the people in Innoval Engineering International have given a lot of seminar talks for the benefit of the students. I thank Mr. Guna for extending his service to our college as well as for the benefit of all the students of the Ishwari team. Then I congratulate Dr. Anthony and Dr. Billy for making this workshop to happen today. And of course, today nowadays you see, previously when there was AC, yes, we are comfortable. Then if the chillness is going to be more, everyone say it is, yes, we are very comfortable. But today in this period of pandemic, and there is, whenever any says air conditioning, there is a little bit of apprehension. and even the government have made a lot of restrictions regarding the usage of air conditioning. So in this situation, now the people have started thinking about the quality of the air conditioning, how far it is going to affect the health, and how we can improve the performance of the air conditioning. So in that direction, I think the ISRE chapter of Eastwood Engineering College has made a right step in the direction where the quality of the air in the AC system, how we can improve that, and how we can better design for the improved indoor air quality. I think they have made a right step in that direction. And I congratulate Dr. Anthony and Dr. Dilly for making such an arrangement. And also, I wish that all the students will get benefited by this, since they are going to have a lot of hands-on calculation and other things. Definitely, this will be of useful to them. And I wish the function to be a grand success. And I expect that more such event or more such workshops to happen in our college. I know the birth of ISRE chapter in our college. Now it has got the best chapter award in South India. I think now it has more responsibilities. And again, when I say responsibilities, I think it should not stop with the doing of many activities in our college alone. Probably they have to extend the support to other chapters of South India, so that the ISRE chapter, under the guidance of Dr. Anthony, should be as a big name, not only for Dr. Anthony but also for our institution. So I wish the function a grand success. Thank you for giving me the opportunity. Thank you.
Thank you, sir.
Thank you, sir. Now, I call upon Vishnu Priya to deliver the chief guest profile.
Good morning to one and all present here. Mr. Guna has done his diploma in refrigeration and air conditioning and his bachelor's in engineering and technology in heating, air conditioning, ventilation, and refrigeration. He has been a project engineer in Blue Star Limited in the year 1999 and a part of Honeywell for 3 years as the delivery lead and the integrated team lead, and as the managing partner in Ad Design Engineered Solutions, and currently in Innovel as the managing director, and also he has been the founder and the founder director. He is a well accredited professional, lead accredited professional, and also an Griha evaluator. It's an honor to have you here, sir. Thank you.
Now, I request our chief guest, Mr. Gunasekar Raju, Managing Director, Innovel Group of Companies, to address the gathering.
Very good morning, and thank you, Eastwood Engineering College, for first of all for organizing such a wonderful workshop. And I'd like to thank the principal, HOD, and Mr. Anthony and VP for giving such an excellent opportunity. See, when we started, I just like to highlight few things which students has to focus. So empowering youth is the best thing that anyone can do. On top of earth or wherever it is, it's the main thing that we need to do. So we're very happy, and I would like to thank our team who were interested to be a part of this workshop. And now the main heroes are only the students, right? So if you look at in my career, when we have started 20 years back, we didn't get an opportunity, first of all, to learn things. Now, here, I think ISRE has organized a wonderful event like this, a workshop for the students. You should not focus on winning this competition. I would rather prefer you to gather the information. Maybe we can try to gather information what we bombard you the whole day. Definitely, it will help you a lot. For example, I'll highlight as one incident happened in my life. So I was forced to attend such an event like this. in 1999. I was not interested because I was a student at that point of time. But the presenter has given few information which it has gone to my mind. When I applied for a job, I won that job only based on the information what I got from that particular incident. They were given very simple things, but I couldn't even understand completely. But based on what I gathered into my mind, I posted those words to the committee, so I got selected. So that was the first thing which I would like to highlight. And second thing is, now we will give you the concepts how you have to you can do the design for the IT building. There are two aspects to it. One is the technical aspect, and other one is the common sense. So I've seen in my experience, only the common sense only will win. For example, when we design IT building, you should know how the IT building will work. Sorry, you should first of all understand how an IT building will work. That is very important because the way IT building works, the way mall works, two different things. So you try to understand the different functions inside the IT building, like say open office, closed office, perimeter area, canteens, and pantry, food courts. So try to understand those concepts first, then get into technical part. Now, I don't want you to first look into winning the competition. Rather, you should try to understand the concept and present the concept to an extent possible. And now the calculation, whatever HOD listed, Mr. Anthony has listed, there are too many calculations. It is very difficult to present to the competition actually. So you have to split that into among yourself and take one activity at a time. You can give the subtask to multiple team members. So to do that, so that they will know some calculations, and later you can know each other. You can discuss and you can know. So that's the second thing that we should do. And we will touch mostly on the common sense part rather than detail engineering, because detail engineering anyway you can learn by books. So you focus on learning the common sense part of the whole workshop. Now we have good experienced professionals in our presenters like Vaisali, Muhammad, and Sirajuddin, and then Rigo. I thank all of them, and I request all the students actively be a part, and you ask questions, and even post event also you can ask questions. But try to learn from these experts, and never try to copy this. You try to do it from yourself, and do not focus on winning the competition. Just focus on learning things. Definitely, you will win the competition. Thank you very much for the opportunity, gentlemen.
Thank you so much, sir.
Thank you, sir. Now, I request Dr. Dilli Babu, History Coordinator, to deliver the vote of thanks.
1 minute, Swati, 1 minute.
Yes, sir.
Sir, I request Dr. Arivadan to address together. Sir, Arivadan, sir. Okay, so I think you can go ahead with the presentation. Maybe I will request him to do it in the next presentation. Okay, before the next presentation. Okay, okay. Please proceed with the vote of thanks. Swati. Okay.
Yes, sir.
I think he is ready. Swati, you can proceed with the vote of thanks.
Dilli Babu, sir. I request Dr. Dilli Babu, sir, History Coordinator, to deliver the vote of thanks.
Hello. Hello. Dilli Babu, sir. Hello. Okay, no problem. I will deliver the vote of thanks. On behalf of History Student Chapter of Ishwar Engineering College, I would like to extend my sincere thanks to the management of Ishwar Engineering College, namely our chairman sir, our co-chairman sir, directors, principal sir, HOD sir, for giving us the opportunity for conducting this program in our institution. And next, I would like to extend my sincere thanks to versus Innoval Engineering International Solutions. So when I requested them to make the for this program, so immediately they obliged for this program. So there is a lot of support from. So all the topics are handled by a single company. Okay, so that is the specialty of this program. So this is for the continuity. This is for the continuity and for the better explanation for the students. So I would like to extend my sincere thanks to the Mrs. Innoval Solutions International Private Limited. And next, I would like to extend my sincere thanks to history office bearers. So we have our history office bearers. I think our president was there, Mr. Ali Sodai, who was there here. Our student chair, he is also here. Mr. Deepak, he is also here. And our incoming president, Dr. Arivargan sir, he is also here. So thank you for your sincere support from History Chennai chapter. And also I would like to extend my sincere thanks to the national team for student activity, for approving this program and for helping for conducting this program. And next, I would like to extend my sincere thanks to history office bearers of Ishwar Engineering College. So they have done a lot of homework for conducting this program. Thank you, everyone. Also, I would like to extend my sincere thanks to all the participants who are from Tamil Nadu, from neighboring states such as Kerala, Karnataka, and Andhra Pradesh. And also, I would like to extend my sincere thanks to the faculty members of Department of Mechanical Engineering of Ishwar Engineering College, who have extended their sincere support for this program. And overall, I would like to extend my sincere thanks to the divinity for wonderful inauguration, and that would extend for the conduction of program also. Thank you, everyone. Thank you for all your support. Thank you.
Thank you, sir.
Okay, so now we will continue with our presentation. Okay, so now we will be having the. Okay, so the first presentation. Yes.
Yeah, Anthony sir, just one point before I forget.
Yes,
Anthony, sir, I just want to inform our ISRE team members.
Yes.
There are people with a lot of connects and networking, and also to the many participants that
Yes.
our college is one of the recipients of Samruddhi project funding from ACTE. This fund is to be used only for incubation. And we like to have incubation center, at least 10 such incubation centers. We have permission, we have funding. So anybody interested, I will request Dr. Anthony to kindly coordinate so that we can support the students in their incubation activities also. Okay, sir. Thank you.
Yes, sir. Yes, sir. Definitely we will do it. Thank you,
For
sir.
Samruddhi. Yes, sir. Yes, sir. Thank you, sir. Best
Thank you.
wishes. I'm seeing a lot of growth, sir. Thank you, sir. Thank you.
Thank you, sir. So next we will be starting our the first session. So before that, I would request Dr. Arivargan sir, who is here, to say a few words about the program. I think he was a little bit busy. So now I request Dr. Arivargan sir to say a few words about the program. So before the start of the session.
A very good morning to all. Very happy to see that more than 50 students have registered for this one-day workshop conducted by ISRE on design of air conditioning system for an IT building and to achieve indoor air quality. It is a very nice initiative taken by ISRE student chair of zonal chair of ISRE. We thank the industry collaborators, Innoval Engineering, who have agreed to disseminate knowledge through this one-day workshop, which will facilitate the students to participate in the the national design competition, which is arranged by ISRE shortly. We thank you, the industry, and we thank the principal of ISRE Engineering College for facilitating to conduct this program in their under their auspices. And I thank the zonal chair, Dr. Anthony Arulraj, the chair of the student chapter faculty in charge, Dr. Dilli Babu, and student chair, Mr. James Deepak, and all the ISRE officials who have lent their support in conducting this event in a grand manner. Definitely, we hope students will get a lot of benefited. We welcome you, and I leave it to the first session speaker. Thank you.
Thank you, sir. Thank you very much for your support. For your information, we have 95 participants, sir. I think a few of the participants will be
joining later.
Yes, sir. We have 95 registrations. We are expecting 95 participants to attend, sir.
Great, sir. Great going, sir. Great
Thank
going.
you for your support, sir. Thank you. Within we can start the first. We can start preparing the first session, sir. Regobert, sir.
Sir, good morning, sir. Rigo here, sir.
Good morning, sir. Very good morning. So we can start our first session. So we will have an introduction of the speaker, and after that we will start the first session. Vishnu Priya?
Yes, sir. I'll start.
Yeah, you can start the introduction of the speaker, and then we will start the.
Mr. Regobert has completed his BE Mechanical Engineering in Anna University, Chennai. He is a professional in design, engineering, and construction commissioning management, general technical requirements preparation, field engineering coordination, detailed engineering, calculation review, and so on. His skills are chiller plant sizing, heat load and energy simulation, design detailing, equipment selection. He has a professional experience of more than 9 years, and he has been a part of Ad Design India, Ella Green Building India, Inception India, and now as a part of Innovel International Technologies. He has a project expertise in industrial buildings, commercial buildings, substations and power plant, IT offices. His design tools are HAP and IESV. It's an honor to have you here, sir, and it's good to see you again, sir. Thank you, sir.
Okay, fine. Thank you, Vishnu Priya. So I'd like to thanks to Ishwari College staff management to given a nice opportunity to present this thing. Okay, so I'll just start with, I'm going to share my screen. Okay, can you see my screen?
Yes, sir.
Okay. Okay. See, here last time we had the same thing. So my request, so let us have an interactive session for this this project. So for what are this presentation? So everybody, so use the chat box effectively. If you have any concern, just text it, or if you can unmute and you can raise a question then and there, then we can discuss on this topic. Since we have a very limited participants, so we can directly interact one on each other and can easily proceed. Okay, so to start with this, just wanted to check with you. Can you see the first page? What exactly it is? Somebody can say. Unmute. Hello. Anybody can say. I'm expecting answer from students. what exactly it is. In a first screen, I have shown some lot of pipes and other things are there, right?
Duct system, sir.
Duct systems. Okay. Any other answers? Chillers, Ganesh. Good. Water cooled systems. Great. Okay, I'll tell you. Okay, so this is going to be a chiller plant. Just imagine chiller plant room. This is how the chiller plant room it's going to be. So you definitely you would have come across a lot of technical training programs. So what is the main heart of a system is called our chiller plant system. This is a chiller plant has been served. It is each chiller is around 5,000 TR. Just imagine you have 14 numbers of 5,000 TR. Is approximately some.
Sir, you can put it in presentation mode, sir. I think it is not in presentation mode.
Okay.
Thank you.
Okay. So this is going to be in a 5,000 TRs of each chiller, which is 14 numbers of chillers is being placed in this room. Somebody is saying it's a duct. Yes, it is not a duct. It's a chill water pipe, which is going to be more than a meter dia. See, why I'm going to say I want to show the screen, because see, people are assuming it's a very small industry, just 100 TR, 200 TR. It's a very limited capacity. By seeing this, you can just imagine how the chillers has been designed, how huge, how massive the chillers has been designed for the building. Why I'm specifically highlighting here is, if you see IT parks is nothing but where you will see a lot of buildings. I'll just come to that part. So if you see IT industry has been origin in India in 1967. Okay, so TCS, everybody knows TCS. They have actually made industry into a very boom thing. So they came into they started a business with foreign guys, and in the year 1967 it has been origin in India. So any IT industry, it is a combination of this BPOs and IT services. So this plays IT industry plays a major role in the GDP for our organizations, for our country. Okay. Similarly, SEEP is nothing but SEEPs. So it is what is that? It is industrial park. It's an IT related industrial park which has been developed in Mumbai. So there, if you see, they have identified on the campus. So whatever the IT companies and whatever the industries they have been developed in that location. So in 1973, this was started in Mumbai. So where a lot of companies came and they have started their factories and IT sector. So a lot of things has been origin in CPAs. Okay. So likewise, we have a different IT parks. So IT parks, if you see, even in Chennai, you can see the DLF IT park in Ramavaram. Likewise, we have across India, we have very huge numbers of IT parks we have. Techno Park is a first IT park in Kerala. It was started in 1971. So likewise, we have a various huge parks are available in India. Okay. So just wanted to show how the IT park has been designed. I have just shown it on left hand side. If you can see master plan, right? So you can see 1, 2, 3, 4, 5, 6 like that. So those entire thing is a buildings. It is not something very smaller rooms. It's a building. Each block has their own number of floors. See, for example, 1A, if we see 1A is having around 10 floors and 1B is having some 10 to 12 floors. Likewise, you can just imagine how huge has been industrial IT parks has been developed. On right hand side, I have shown some number of floors, build up area. See, all these are this information. This what are the number of floors and a build up area. This is for Bangalore. There is a place called International Tech Park, ITPB. It's a very familiar tech park, where you can just imagine each has multiple building name. Discover that building has G+13. Just imagine it is around 2 lakh square feet. So total build-up area. Each floor is coming some 2,000 square feet. See, we are discussing one ground. We are purchasing a land, right? It is around 2,400 square feet. Just imagine it's a one ground. But whereas they have developed around 45 lakhs, 8,000 square feet. Just imagine how huge it is. So for our space itself, we are designing such a massive air conditioning. But still, just imagine how how the major role of air conditioning part in the entire IT parks. I just wanted to highlight here. So these are the imagine. Just wanted to highlight how huge it is. There are other concepts called district cooling. District cooling definitely you would have come across. District cooling is nothing but there will be a central plant which will be placed in some location. Like this, we everybody knows that water pipings are running across the city, right? So everybody is getting more metro water. Likewise, the chilled water pipes will be run across the certain area. Okay, so any builder or anybody else who is going to develop their thing, they can take a tap of the chilled water and they can use this chilled water for their facility. That is called a huge district plant room. So whatever the image that I have shown in the first slide, that is for district plant room. Okay, so as everybody was saying that we are looking for this competition, and as rightly Mr. Anthony also said, Mr. Gunashekhar was saying that see, competition is winning a competition is secondary, but whatever the information that we are going to share, you have to browse it, you have to search it. So to search certain information, we are showing some concepts. What are the concepts that we have designed? So that is the reason we are here. And moreover, please don't circle yourself that we have to search only this information or something like that. Even you can browse and you can get a lot of information. Okay, to start with, I've taken some case study, because with the case study only, definitely people will know how to do it. And moreover, we have taken a IT building. IT building, you can see on right hand side, it is an IT building located in Hyderabad. There, if you see it is some 13th floor building. So ground, first, second, if you see, they have taken as an retail space, and fourth, fifth balance floor, it is going to be in an office space. So just please understand, office space is nothing but we used to give a rent, right? So any builder, house owner, they will have a space. Anybody can come and they'll take a rent and they'll go. The same way the IT parks also has been designed. The base builder will design the entire civil structure. So whoever is going to be in their office, they'll come, they'll pay the rent, and they'll be there. They will construct the complete interior, and once leaving, they will demolish the entire interior and they'll leave it. So this is how the market used to have the thing. And moreover, you should understand, there are companies, why they are not purchasing the complete building, why they are not doing the complete business. They have huge money, but they'll not do, because there is a financial part. There will be a financial, because the moment they are going to purchase the building or something like that, that is going to be added in their asset. Okay, they have to pay some taxes for that. Those kind of, for that is the reason they want to show the high expenses. So for that only, they are taking a good space. And moreover, it is easy for them to, the moment they want to change it, or it will be very flexible, so that they can shift from one location to other location. So likewise, I'm going to show how a building, it is going to be designed for air conditioning part has been designed. And people, we don't know how many people can we specify? No, we cannot specify. Can we limit? We cannot limit. Yes, there is a limitation. We have to highlight whoever the guy who's going to be in a tenant in our building. So we have to say, so we have designed for certain limitations. Any design, they will have a certain limitation. So those information has been given by a standard called National Building Code. So they have specified certain standards. So based on that standard, we can take it. See, for this building, so we have considered occupancy rate. So definitely any floor, there will be a number of occupants, right? So we have considered some 80 square feet per person. Per person is going to consume 80 square feet. So likewise, we have considered approximately 2,500 workstations. Okay, so 2,500 workstation people is going to be occupied in that floor. Considering 2,500 occupants, so we are designing that floor air conditioning part. Similarly, everybody is aware that server load. Server is nothing but something wherever we go, we will have some server. So any data, everything, what are the networking cables, so anything will be taken from them. Though the office is going to be running for 8 hours or 6 hours, but there will be a server, there will be in server rooms, there will be a critical room which will run for 24/7. So likewise, the same way, the server room, we have to design for 24/7. For example, the people who's going to be there in the building, who's going to enter into the building, so he will switch off the air conditioning in the after 6 or 7 o'clock. But for the server, we don't know. It's how it has to be run, right? So I cannot for one server room, I cannot run the entire chilled water plant room. So for that, what we used to design during before a building come into the picture, we will discuss with the structural and architects. So we need to have a separate standby unit for that. So we need to have each floor, we need to have a service balcony, so that any tenant who's going to be in the who's going to be a part of a building, so he may have server rooms, he may have an UPS rooms likewise. So we have to have a separate space for that outdoor unit location. So we will give a requirement. So generally, people, you should understand, any IT building, we have to be there in the starting stage. You cannot be, once a building is being constructed, after only you are getting on board. That's not a right way. So before designing, when the civil engineering or when client is going to discuss certain things, yes, our MEP or HVAC guys should be there along with them. Then only we will be able to know what is our requirement, whether our requirement is being considered by architects. So likewise, we have a lot of points to be discussed in this thing. Okay, so likewise, lighting, occupancy rate, and see, if you see a retail shop, office floor, you can see what is the workstation, and while retail load, if you see, the loads are very high. Retail shop is nothing but we used to go this branding showrooms, right? So there, if you see, the lightings are very huge. If you enter into Sarada stores, you can see, just imagine in a center area, they would have given a huge lighting. They'll not see the power consumption. They'll see only how bright it is, so that it is going to attract the people. So that is the reason, even retail floor, if you see the lighting, power consumption, electrical power consumption, it's very high, because they want to attract the people by showing how it is beautiful it is. Okay. So any clarification, any IT parks, I've given a list. So input consideration, maybe after this session, we will have another session called a heat load calculation. There are one Vishali will teach you what are the heat load parameters. Yes, definitely you guys would have aware of those points, but still she will teach what are the parameters that we have to consider. Likewise, she's going to list out. So any clarification on this part, so that you can stop and you can ask the questions. Okay, fine. Maybe we can have any question, if you can just note down. Maybe later stage you can get that thing. So we will have any. So as I was saying that we will have an interactive session. The guy who's going to raise a good question, I am going to give some rewards for them, or any. It's a good answer if you can get from your side. I'm going to have a good rewards for you. Yes, last time we have done the same thing. Is going to be happen this time also. So maybe you can put it in the chat box. Since I was sharing the screen, I couldn't see the chat box. Anyway, I'll just come into that. So if you have any concern, just stop. You can unmute and you can raise the question. Okay, I'm just proceeding with the next slides. So system architecture. So likewise, I was saying it is approximately some 13 floors. So we have taken some 10 floors, the total load. Each floor is having a different load. So if you can see ground, first and second, almost 3 floors, if you see, the capacities are very high, because it's all retail shops, and other ones are office buildings. So all put together, if we have done the heat load calculation, it comes around 750 tons. Just imagine, 750 tons is nothing, huge capacity. So any office, the people is going to, when the entire building is going to be occupied, then it is going to be in a 750 ton. Just imagine, 750 tons is a very huge capacity. But though it is not going to be in compared to the district cooling, it's very lesser. But just imagine, 750 tons is very huge for an IT park. But we cannot stop them, or we cannot ask them, people should not come this time. Just imagine 750 tons, what basis the chiller configuration has to be designed. If after construction, maybe we cannot assume that all 10 floors will be occupied in the first year or second year. So only maybe multiple floors the people will be having, or 50% or 30% or 60% only the people will be occupying. So for that, we have to select our chiller configuration in such a way that, so that we can use the one chill. See, for example, 70 tons. If I select 750 TR into one number, then only 2 floors has been occupied. I cannot run the 750 TR chiller only for 20%, because it's not going to work. Okay, so we have to optimize, we have to identify how the 750 can be splitted, so that will have standby, as well as that will have an energy efficient part also. Maybe I'll come across. So likewise, we have a different thing. So everybody should definitely know how the chilled water schematic or something. I'll just show it how it is. So this is going to be a chilled water schematic. I've just taken a screenshot of a CAD drawing, because you should be understanding how industry is practicing. I can show some image of schematic, but you should understand it's just a schematic drawing. But this is how the industry is going to be. You can see a cooling tower, right? On top, 3 blue colored box. Can you see a 3 blue color box that is going to be in a water cooled chiller? From the water cooled chiller, chilled water is going to through a pump, secondary pump. That is from their pump, it is going to be in the load, and we have another primary pump. So pump system. Maybe if I'm going to cover that part, that's going to be any huge. But I'll say the primary variable. Primary variable is nothing but from the chiller. There, from the AHU, it is directly coming into the. It's just a pumping system where whenever there is a reduction in load. So, for example, in a primary variable system, if you see out of 10 floors, only 3 floors has been occupied, or only 4 floors has been occupied. There won't be any flow in the different floors AHU. For example, other banquet floor, there won't be flow in the AHU. So there will be a valve which is going to be sensed. Okay. So the moment the valve is going to be closed, then the flow requires very lesser. So for that only we are placing some sensors. So the sensor will give information to the pump to reduce the flow. That is reduce the speed. The moment the speed is getting reduced, the flow rate is being reduced. So automatically we are running that pumping system in a very slow manner. So there is going to be an energy saving. I'll come across that there are different concepts of variable frequency. That likewise we have a pumping system VFDs and chilled water VFDs. I'll come to that part. So you can see a schematic chilled water piping. So all just imagine it's all chilled water piping. So all green color lines are chilled water piping, and the blue color and red color lines are condenser water piping. So here we have shown that we have water cooled chiller with 3 numbers of cooling tower, 3 chillers, primary pumps and secondary pump. There is another pump called red colored, right? So this is going to be a condenser pump. So one set of circuit is being taken to the AHU, that is a load, that is called a chilled water side or evaporator side, and another set of this complete is going to be in a condenser side. So if you see condenser side, it's going to be again a water, ambient water. Normal hot water has been converted into an ambient condition. So that is how we are used to design. So this is going to be in a real chilled water schematic. If you see a section, this is how this is going to be. So you can see the chiller in a section, how the pipe has been run and it has been taken to the cooling tower. From the cooling tower, how the water has been transferred to the condenser side. So meanwhile, you can see the pumping. So there are different types of pumpings are there. Maybe I'll come through this. So the moment any system, when we take when we select a system, just wanted to have one small chat box. Okay, so on what basis somebody has been raised a question. So Vijay Ganapati, why ground floor and first floors have a higher total coil load? Yes, it's a good question. So if you see, the building has been designed first and ground floor, it's only for retail shop in the sense I was saying that there will be a lot of branded showroom, so they are going to consume more load when compared to office space. So that is the reason ground and first floor has been designed for higher capacity. It is nothing else. It is not something very different strategy or something like that. It's a regular thing. There will be a huge load on that part. Okay. Vishnu or anybody else, can you share the screen so that I can discuss on this chat box, so that if you can present on this from your side, it will be helpful for me. I'm going
Yes,
to stop.
sir. I will do, sir.
Okay. You have that presentation, right?
Yes, sir.
Okay, done.
Just give me a minute, sir. I'll do, sir.
Okay, done. Great. So meanwhile, you can list out your questions. So my question was to you guys is, please tell me whether the chiller, on what basis you are going to take. See, for example, just assume in your room for your house, you are going to purchase an air conditioning. On what basis you are going to purchase? Are you going to purchase based on the capital cost, that is an initial invest, what are the amount that you are going to pay? Is that the cost, or power cost, or maintenance cost? If you can go to this, you be here in slide 5. Okay. I think people today early morning oh, it's a holiday, so people are very sad or something like that. Oh, guys, come on. So I'm expecting a lot of questions from your side. Last time I had a good, really good response. I'm unable to answer your question because I was continuously getting a lot of message, but I don't know why today it is. Unless until you are going to raise a question, I'm not going to leave you guys. Any answers, any questions? Say, for example, I have raised a question for you. When in your office or in your residential, if you are going to purchase an AC, that's split AC, are you going to purchase based on the capital cost with you, or are you going to purchase a cost with the running cost based on the running cost or maintenance cost, or what it is? Anyway, not a problem. Maybe I can can start discussing on the topic. Okay. Ramya, Vishnu, can you come down? Slide number 8. Okay. Saswat Khan, you are saying that it is going to be a running cost. Okay, it's a good answer, but I'll come to that point how it is actually. Okay, I'll before that I'll just wanted to list out what are the different options. You just come down next slide, Ramya. Sorry, Vishnu. Next slide, Vishnu. Okay, so for this, before that, I'll just highlight for this building. So we have designed with 2 air-cooled system and 1 water-cooled system. Okay, so this is the system we have designed for this space. Okay, so if you see here, we have various options. Okay, we have to have a different option for this because we cannot have one option. We cannot select with the one standard option. I have just highlighted. First option is nothing but a regular air-cooled chiller and regular water-cooled chiller, 2 numbers of air-cooled and 1 number of water-cooled. So just imagine 750 ton has been designed for 2 with 2 air-cooled and 1 water-cooled. So option 1, that is option 1 or case 1 is going to be in a regular system. Case 2 is nothing but it's going to be an adiabatic kit. Adiabatic kit is nothing but it is we used to have this air coolers in our residential, right? See, on olden days, if we see, people used to pour water on that. I have got one good answer. Dinesh Kumar should consider all 3 factors like. Yes, Dinesh Kumar, I need your contact number so that I can give a good thing. So it's a perfect answer. We have to see all parameters, 3 factors: purchase cost, that is capital cost, maintenance cost, and running cost. I'll explain you in this next slide. So how it has been designed. So Anurag, it is not only a purchase cost. It is we have to see the running cost if we can. So I'll cover to the next topic. Dinesh Kumar, can I have your contact number and mail ID or something so that I can have a good thing for you? Meanwhile, I'll just proceed with this. Configuration has been selected for this thing. So if you see here, there is an adiabatic kit. Adiabatic kit, I was saying that Dinesh Kumar has sent a mail. Okay, thank you, Dinesh. Dinesh Kumar 7076 gmail.com. And if you can send your mobile number, it will be easy for me. Okay, adiabatic kit is nothing but water cool. We in our day-to-day life, maybe 10 years before, people used to have one bigger machines, right? They will pour a water and that is going to spray, and from one fan it is going to take it, and you will feel a comfort. The same way, the ambient temperature. If you see the adiabatic kit is going to spray a water in the air. Okay. Just imagine the ambient air is 40 degrees Celsius. Okay, the 40 degrees Celsius of air is going to cross the coil. It is going to pick the heat and it's going to be converted to 60 degrees or say 55 degree. Just imagine I'm going to, by pouring the water on the condenser coil, I'm going to convert this 41 degree to a 27 degree or 30 degree. Okay, which is almost equivalent to a bed bulb temperature. So somebody can say what is the wet bulb, what is the dry bulb temperature, wet bulb temperature for Chennai condition? Wet bulb and dry bulb for Chennai. Whether the wet bulb will be higher or dry bulb will be higher. It's a basic question for you. Maybe. So Kanah, you have answered 38 to 30. Okay, 38 is a dry bulb, wet bulb, and okay, it's a good. Isaac, yeah, Isaac, it is not acceptable. So you are into an industry, so it's only for students. Though you are looking as a student, but it's not applicable for you, Isaac. Okay, so okay, almost everybody is almost the same, and the answers are fine. So the 39.4, it's an dry bulb condition for peak design for dry bulb, and wet bulb it's going to be at 27.6. Okay, so everybody is aware of this information. So just imagine this adiabatic kit, if it is very efficient, just imagine this 40 degree, you are saying that 40 degree and WBT is going to be 23, right? This 40 degree, if the kit is going to be 100% efficient, this 40 degrees directly is going to be converted to a 25 degree or 26 degree. So that just imagine 26 degree of air is going to cross the coil and it is going to pick the 65, means how efficient it is going to be. Okay, the heat has been picked easily because the heating from 40 degree, picking the heat from 40 degree to 55, and we are supplying the air of 32 degree or something. Just imagine how efficient it is going to be. Okay, so this is the adiabatic kit. It's going to be a very huge impact in our design. We have done a lot of projects. You should browse the information on this adiabatic kit for air cooled chiller, because there will be a water consumption. It's going to be higher, but that is not going to affect any coil thing. Maybe if you have any clarification, you can have I can share some videos on the adiabatic kit. Okay, so if you see the adiabatic kit, that is going to spray water. From that, water is being converted and the heat is being picked, so that is going to be an efficient system. So it is applicable only for air cooled. So option 1, option 2, we are going to have air cooled chillers are with adiabatic kit and conventional water cooled chiller system. Similarly, option 3, we are going to have VFDs. Okay, just imagine VFD. VFD is nothing but variable frequency drive. Variable frequency drive, it's a very, very simple concept. It's a drive which is going to reduce or higher the speed of the compressor. There are a lot of compressors there, because everybody should know at this stage, everybody should know it is a fixed speed compressors and inverter compressors. Similarly, the same way, whenever there is in an IT park, everybody knows that the load will be very lesser. Okay, or there will be a fluctuating load. Sometimes people will be higher, sometimes people will be lesser. So due to this fluctuation, the load will be varying. So for that only, we have to design a compressor. We have to select a compressor with VFD, because based on the load, the compressor speed is going to vary. Just imagine there is a fan law. The speed is 3 times of proportional to the power consumption. It means inversely proportional. Sorry. If you reduce the speed by 1, then the power consumption is going to be saved for 3 times. So that is a fan law. The same concept we are using. We are going to reduce the power compressor speed. So we are going to save the energy of 3 times. Okay. The same concept we are using, there will be a VFD, variable frequency drive for compressor. So based on the load, the compressor is going to be so we have one case fight, it's going to be an adiabatic kit and the VFD. So if you see if you see this case, we are using only 2 energy conservation measures. One is going to be an adiabatic kit and another one is going to be in VFD. Okay, so with these 2 options, we are going to have a different thing. I'll just list out. So I was saying that the chiller or any system while selection, we have to see all 3 costs. Okay, capital cost, running cost, and as well as maintenance cost. Okay. Can you go to next slide? Okay, so if you see, we have worked out in the various options. So in the capital cost, if you see the capital cost, since I've shown the entire item, but you just see the chiller cost is going to be huge when compared to other costs. Okay, just imagine almost some 60% of total cost is going to be in chilled water system, chiller cost. Okay, so that is the reason I've seen it. So if you can see the figure, just imagine case 1, it is going to be 3.7 3 crore 78 lakhs, whereas in case 5 it is going to be a 3 crore 92 lakhs. So there is a huge investment on case 1 and case 2. Okay, similarly for case 1 and case 2, case 1 and case 2, it's going to be in maybe 11 lakh, and case 1 and case 5 it's going to be something around 2 12 14 lakh something. Okay, similarly if you see the energy consumption on right hand side, I can see an energy table, right? So the energy consumption, if you see case 1, it's going to consume 2.1 crore. Just imagine 2.1 crore, whereas in case 2 it is going to be in case 2 it's going to be 1.94, and case 5 it's going to be in 1.91. Okay, so we have 5 different cases, all 5 different cases having a different power consumption. Okay, and similarly the maintenance costs remain same. So every year there will be a depreciation. So the depreciation, you know, what exactly it is depreciation? Any answers? Depreciations. So you should know these words, okay? Because you cannot say this is going to be answer. I am an engineering student, I know only this kind of technical things. Depreciations all comes to the accounts or management or economics or something like that. So you should know. Any engineer should have this basic information. Okay, depreciations. Like why there is a reduction in cost? Kana, you are saying reduction is called product become old. So as Prashant, Sharad, that's a perfect answer. So every it's not throughout the period, every year there will be a reduction. So that we have to consider certain depreciation costs. So somebody may raise a question: will the power consumption will be same for all 10 years or 5 years? No, there will be a reduction in the performance, in the unit performance. So we have to have that part. So how do we identify whether there is a depreciation? How do we identify? Means, so there is a system called building management system. So all data will be stored in the building management system. From the system we are going to have a different observation. So by seeing the graph, so in the month of May 2019, what is the power consumption? You can take in 2020 May, what is the power consumption? By comparing these two things, we can identify the load, and we know this is the okay, both are average same load, but the power consumption is higher because of the depreciation. Not only depreciation, sometimes there will be an issue. So those points can be discussed in that thing. So by seeing this LCC, you can see we have different capital cost and annual energy cost and maintenance cost. Can you go to next slide, Vishnu? Okay, by seeing, is that the graph is visible? I think something's missing. Okay. By seeing this graph, if you see total cost, annual energy cost, maintenance cost. So first year, this is called a life cycle cost. People used to please understand, life cycle cost is a very important terminology which is going to kill you throughout your career. Okay, so life cycle cost, we have to select any equipment, any part, anything. Even in your residence also, you can just do an energy calculation. Anybody can do it. It's not something very professional can do. Just calculate a split AC. You are going to take a regular split AC and you are going to invest an inverter. What is the cost that you are going to pay? By paying extra 5,000 cost monthly, are you going to reduce 500 rupees? Yes, 500 rupees. So within monthly, you are going to save 500 rupees. Means just imagine within 10 months, you are going to take that 5,000 rupees. So within 1 year, whatever the investment that you are put in the inverter, you are going to get it that within 1 year. So split AC life, it is going to be more of any 3 or 4 years, we know. So if the life cycle is going to be, or the return on investment, the return on investment is nothing but at which year it is going to recover the entire, what are the additional investment that we have done with compared to other one. So on which year we are going to take it, that is the life cycle thing. So just imagine if you are taking in a split AC, if you are getting a split AC in your thing, you are going to get after 7 years or 6 years. It is no worth in investing that part, because the split AC life is going to be in within 3 or 4 years. Okay, so we have to be very careful on which year it is going to be, we are going to recover. That is a major role. By seeing this graph on first year itself, because I am getting it, because I am just imagine case 1, I am spending 6.035 crore. Okay, first year. Whereas in other option, I'm though my capital cost is 11 lakhs higher than this, but I'm saving more than 12 lakh in the first year itself. So there is no curve which is crossing in this direction. All curves has been parallel, because the capital cost, if I'm going to recover in third year or fourth year, there will be curve which is going to be crossing each other. So that point is going to be in a return on investment. But here there is no curve is getting crossed because I am taking in a first year itself. Okay, just imagine by adding an adiabatic kit, you can see the difference in the energy cost. See how the energy cost, it's going to be 6 lakh plus 19. Oh, sorry, it is something more than that. It is 6 lakhs and 19. 25 lakhs I'm saving in the first year. 25 lakhs of energy saving is directly happened to this system. Okay, so by seeing first year, second year, third year, you can see what is the total cost. By seeing this answer, you can see a cost. Option 2 is going to be an efficient system, so which is around 6.17 crore. So there is no crisscross in that part. So we are going with the option 1. So option is nothing but air cooled with adiabatic thing, and there is no VFDs are available. There is no, we are not preferring any VFDs. Okay, so this is how we have to calculate any equipment life cycle cost. We have to think. Okay, so we have to work in 2-3 options. During an industry also, you cannot fix one option. You cannot go with only one option. You should have multiple options. We should try. All these are energy simulation. It is not something very tool or something like that. It's a very simple. Anybody can do this calculation. I have shown it, right? We know how to calculate the capital cost, energy cost per year. What is the cost, and maintenance cost? You can take it. Even in Excel sheet, we can do this life cycle cost. Okay. So next slide, please. Okay, so this is going to be in a pump selection. Now we have seen this different chiller selection. So once the chiller has been done, then we are going to have the pumping system. Pumping system, there are different types of pumping system called vertical pumping, end section pumping, and split case pumping. These are the different cases. So based on our application, we can use this pumping system. But I was saying that we should choose a pumping system. Pumping system is a main system where the complete performance of systems depends. Okay, so by seeing this thing, you can just imagine the vertical pump, which is not going to take the load, which is not even touching the floor. Just imagine, it's not even touching, it is hanging. So this is going to be, I think this is going to be more than tons of weight which is placed here. Okay, so the vertical pump or end section pump, you can see this, right? In end section pump and vertical pump, all different applications, but the concept remains same. Whatever the flow requirement, entire thing is going to be remain same, but the location, the pipe entry, space concern. So we, based on this, we can choose. But the split case pump will be always chosen whenever there is a bigger capacity. The split case will be chosen for that thing. Otherwise, you can go with the vertical pump and end section pump. Again, in end section pump, we have a two pumping called long coupled pump and a short coupled pump. Long coupled pump. So you can note on this point. I can just share the information, but you try to browse the information. Any answers for long coupled and short coupled pump? Any answers? By you please try. It is not something very technical. Okay, even Mr. Guna was saying that you should use the common sense. Common sense is nothing but by saying in the word itself, the answer is having that thing. Long distance covering, short distance covering. Sorry, sir, that is not a right answer. The word called coupled, just imagine coupled. We come across, right, in first year electrical and electronics, you drive system. So there you will have a pump, this drive, the motor which is going to connect. It is not in electronics, it's going to be in fluid dynamics, I think. I'm not sure on that part. It is nothing but the pumping. Please understand, people, there will be a motor is going to convert the electrical energy into a mechanical energy. That shaft which is going to be connected with the pumping, that is impeller, right? So that impeller, the shaft, if the shaft is too longer in the sense, it's not something a distance. If the motor is directly put it in the pumping, and it is going to be in a single set, as a single skid. In a single skid, that is going to be short coupled. Directly it is going to be there. But in long couple, there will be an impeller which is going to be in a prolonged, and the pumping will be in a different skid, and the motor will be in different skid. So we have a lot of advantages and disadvantages in this long couple. Whenever there is a maintenance point, the long couple, the moment the pump we are going to remove and we are going to place the pump in the long couple, again that just imagine that alignment, the pump has to be straight in such a manner to the pump. Sorry, the motor has to be straight in such a manner to the pump so that the shaft is going to be worked efficiently. The moment if you put it in a slight incline, the shaft is going to damage. That is going to affect the performance. That we have a disadvantage in long couple, but short couple, yes, there is. I was saying that based on the space availability, we can select this different pump. So pumping again, I was saying primary variable, primary secondary, primary constant. Like this, we have a different strategy. So you can browse that information. I am expecting you should browse and you should gather the information. It's very well available. Based on that information, you have to choose it. Okay. And similarly, I'm going to the next slide, please. Okay, so I was discussing there are 4 major parts. Okay, one is the pumping, chiller, AHUs. So these are the major parts of the chilled water schematic or any building. So AHU. So I was discussing on the high side system. So chiller, from the chiller directly it's going to be entered into the AHU. From the AHU it is going to be the pump, and from the pump it is going to be to the chiller. So this is the schematics. So likewise for any IT park, so we are discussing on the IT park, it is a base building, bare building, we have to choose in that place. So we have to place the AHUs. AHUs is nothing but air handling units. Okay, so there are different types of AHU: horizontal type, ceiling suspended type, vertical type. Again, the space availability we have to discuss. So this part also I was saying that we have to be interact with the designers from the day one. If you are not designing, if you are not interacting, or if there is no, if the jobs are not as per design, then it's going to be very tougher, because once the construction has been done, you cannot place the AHU. You have to place the AHU in the open office. There is going to be a noise, water leakage, maintenance guy is going to come. Lot of things is going to be a very issue for us. So we have to place the CSUs or chilled water AHUs or AHUs in the right manner during preliminary stage. That is during design stage itself. We have to choose. Next slide, please. Okay, in the AHU, you are saying something a bigger box, right? It's just an empty box. Okay, it is having a fan, coil, and filter. That's it. Okay, fan. If you see, we have a different profile fan, backward curve, forward curve. Like this, we have a different profile fan, which has been shown here. You try to get the information, but the fan plays a major role. Whatever the efficient. Again, if you see, I want to highlight one important. Can this AHU perform chiller, or it is required? Sharath, it's a basic thing. AHU, it is just a box. Okay, so it is going to recycle the air. So supply, it's going to supply some certain temperature of air, and it's going to return. Okay, this chiller, it's going to generate a chilled water. The chilled water is getting cross the coil, and the return air at 24 degrees is going to touch the coil. From the coil, it's going to be 13 degrees Celsius. So the heat transfer has been done in the AHU. So to have a heat transfer, you should have a coil. Okay, same way, to generate the chilled water, we should have a chiller. Without AHU chiller, it's just an air. We have a ceiling fan, right? It's going to be a recirculate fan. The same is going to happen. But chiller, yes, to perform AHU, we require chiller, because the AHU purpose is to remove the load. Without chiller, you cannot remove the things. Okay, why we use chiller instead of centralized? Centralized AC is nothing but chillers. Okay, chillers, pumping, everything is called as centralized AC. And normal AC is nothing but individual DX unit, one indoor unit, one eyewall unit, one outdoor unit. Likewise, that is going to be a regular thing. So any centralized system, we use chiller. Okay, so centralized is nothing but everything has been centralized in one part. From there, it's going to be taken. Okay, both are same. Chillers instead of centralized system, both are same. Okay. Okay, so I want to highlight here, there is a recent technology trends are happening here. EC fans, everybody is electronically commutated motor. It's a recent technology. People are coming thing. The fans the motor has been directly mounted to the fan. It's a direct driven. That is an energy efficient system that recently it has launched. So though it is going to be an energy efficiency, but as a system, if you see the motor efficiency, the fan efficiency, everything has its own efficiency. By adding this efficiency, it's going to be almost similar to the conventional system. But the motor has a good efficiency system. You should browse that information. EC fans. Can you show how the heat has been transferred from one place to order, like any? Sir, yes, sir. We are going to cover in that second topic, sir. Maybe I'll just cover that point, sir. So you are asking to transfer from one space to other order, right? So I'll just show, sir. Maybe after this thing, sir. Okay. So So I was discussing the EC fans, right? So EC fans, it's a recent trend. Fan is being directly mounted. You cannot see the fan. You cannot see the motor. It's a very smaller motor. So that is a recent trend that we are going to have. That is called an fan motor. If you see, there are different IE ratings. IE2 motors, IE3 motors, IE4 motors. Likewise, we have a different ratings. So PM motors are called a permanent magnet motor. That is going to be a super motor. They'll call us a super motors. So you try to browse that information. So gather that EC fans are a recent trend. Now it is everybody is using that thing. And the great information in the EC fan is we don't require any VFDs. I was highlighting, right? The VFD will be there. So the variable frequency is going to drive the speed of the, it's going to control the speed of the fan. Yes, the same thing also is going to happen here. The motor is having inbuilt VFD. We should not have any separate VFD. So it is going to be an inbuilt VFD. By giving the information to the direct to the motor, that we are going to modulate the speed. Similarly, we have a different filters also. Can you come next slide, please? Oh my God, next. Okay, sorry. Can you go previous slide? Okay. See, if we see the filters, we have an MERV filters. We have a different filters, MERV 6 filter, MERV 8 filter, MERV 13 filter. So each filter is going to remove a different size. The filter is being selected based on the size of the particles. So 10 micron, 20 micron, 1 micron, 0.1 micron. So any IT box, if you see, we are using only a pre-filters, but it is recommended to use a MERV 13 filter, that is a fine filter. So that is going to block up to 1 micron size. The moment we are going to increase a good efficient filter, that is going to affect our fan static. Fan static is nothing but, just imagine you just take a cloth, just blow from the cloth, okay, with an ordinary cloth. And if you are going to take a high dense cloth, if you can blow on that part, then that is going to be we have to spend more energy, because that cloth has very multiple, very small pores. So we cannot blow. So we have to blow with high energy. Okay. The same way, the motor is also, the moment the filter efficiency is getting increased, the motor selection is going to be increased. For example, same capacity, I'm going to use 3 kilowatt. If I'm going to have a higher filter, I'm going to add an 10 kilowatt or 6 kilowatt or 8 kilowatt motor. So that is going to add a cost, but that is going to be in a good filtering systems. Okay. Okay. Next, sir, I'll just show, sir, because we have already crossed the time. Maybe during visualization I can share that information, sir. Big building chiller. We have, yes, we can use chiller. Can you go to previous slide? Okay, so heat recovery ventilator. This is going to be in a different way. I'm going to extend another 5 minutes for you. Heat recovery ventilation is nothing but, whenever there is a fresh air requirement, right? Maybe next topic she's going to cover the fresh air requirement. So the moment if you are going to add the fresh air, you are going to remove you are going to add a fresh air of 38 degree or 40 degree, and we have to remove that air, because that is going to create positive pressure, right? So we have to add a fresh air, and from other corner we have to remove that fresh air. To remove that fresh air, 40 degree air we have been submitted, maybe next topic, and we are removing 24 degree, because the 40 degrees is getting into the room and it is conditioned, and we are going to remove 24 degrees Celsius of air, right? So we are losing the energy in the exhaust air. So for that only we have a system called heat recovery wheel or heat recovery ventilator. Just 40 degree air is entering into the space, and there will be an air which is going to leave from the room, right? That is going to be a 24 degree. This 24 degree is going to cross the heat exchanger, and the chillness is going to be recovered in the heat exchanger. Meanwhile, the supply air is going to cross that heat exchanger. That is going to pick the 40 degree air, is going to enter the heat exchanger, and that is going to pick the chillness from the heat exchanger, and it is enter into the space. So that is how we are going to have a heat recovery system. So any fresh air system, we have to have the fresh air. It is through heat recovery. Yes, the capacity of chiller is going to be drastically, it is going to be reduced. So any I said we should have a fresh air system. and there is an increased fresh air system. Yes, that's going to be covered in next topic. And one more thing, there is another system called a economizer mode. In the same HVAC can operate in economizer mode. Economizer mode is nothing but in a Delhi, if you see ambient conditions go up to 10 degree or 12 degree. That time we can directly take ambient air without operating chiller, directly pumping into the room, and we can from other side we can take the exhauster. Okay, so we are directly adding the air into the space, and we are cooling the area because I have an ambient condition in a very good condition. Okay, but you might raise a question that when the ambient is very lesser degree Celsius or 12 degrees Celsius, I don't have any heat inside the room. Yes, there won't be heat, but there are equipment load, there are people load. By default, they are going to generate that heat. To remove that heat, we have to add anyway. We have to have the air conditioning. So that is called an economizer mode. Maybe during this session we can have any other question. If you can gather that information, definitely I can answer. So with this, how we have to select? So we have to choose a chiller, right chillers. We have to choose a pumping system, heat recovery, ventilation, and HUs. See, these are all the system selection. We can have a different HUs by adding DC fan. What is the power consumption? By adding a conventional fan, what is the power consumption? Again, we have to see the HUs life cycle cost. Likewise, we can design the thing. So this is I've just covered a basic part of this part. So we can take it forward. So I think we can close this session. Is it time at 8:30 to 9:30? Oh, till 10 o'clock, right? 10 or 9:30? Anybody can respond?
10 o'clock, sir. Yeah.
10 o'clock, sir. 10
Sorry,
o'clock.
guys, I was pushing for 9:30. That is the reason I was rushing for you. Sorry, extremely sorry. Okay.
Mr. Rego?
Yes.
I think you can have a discussion on general chillers. Okay, so if you have some pictures of general chillers, you can share with the. So you can tell them what is a DX plant, what is because questions are arising from that angle only.
Okay.
So yeah, we can discuss on general DX plant, chiller plant, and air cooled. What is water cooled? So that general thing we can discuss.
Okay, done. Understood.
Yeah. We have half an hour time, so that will be useful for the students.
Okay, fine, that great. Okay, so we have used this chiller water cycle. Okay, so you any so far what are the topics that we have covered? Any general questions so that we can discuss this part, so that I can meanwhile I can take this other thing. Any questions? Okay. So there was a question like a chiller and BRF for this. It's a good question. See, actually, we have designed IT park, which is going to be around 14 floor IT park, 14 floor. It is a complete VRF system. Okay. So though it's a client requirement, since if you see the power consumption between the chill water system and the VRF system, that is having a very huge impact. But there was a system we have designed. Just imagine we have designed 14, I think it should be around 20 floors or something like that. Okay, so there we have designed only the outdoor units. Okay, so VRF outdoor has been placed in the terrace, and we are running the chilled water refrigerant pipe, and we are leaving into the entering space of the tenant. Okay, by seeing that, if you just imagine how many pipes is being taken into the things. Okay, just imagine it's going to be a huge thing. Okay, so there if you see, the tenant can decide whether he can go with the ductable VRF ductable unit, or be a chilled water cassette unit, or high wall unit, or even he can go with the AHUs. Recently, if you see there are technology where instead of putting a chilled water entering into the AHUs, we can put a VRF system. VRF system, yes, everybody should aware of this VRF system. VRF system is nothing but same way the chilled water happening. There is a refrigerant going to travel. The refrigerant, instead of chilled water, the refrigerant is going to travel into the indoor unit. The same way, the AHU, there will be a huge AHU, 30 TR, 40 TR, 50 TR. The refrigerant from 21st floor, and it is going to flow, and it is going to enter into the AHU. The AHU, again, it's going to be a regular process. From there, it is going to take that heat, it is going to be travel, and from there, it's going to be in a taken to that room. Okay, so refrigerant plays a major role, but here we have a lot of disadvantages. Number of pipes, just imagine 21 floors, you will see a huge set of pipes which is going to be running from the top to bottom. Okay, there you have a major concern. So we have a lot of disadvantage in VRF system. But for a smaller building, yes, it's going to be an efficient system. I'll show that if possible. I'll try to show that. I'm just showing, sir. I can show the CAD drawings, right, sir? Because it's going to be done in the STA program. I can show some CAD drawings, right? Our project CAD drawings. Anthony, sir.
Yes, sir. You can do it, sir. No problem.
Okay, that's it. I'm just opening a few CAD drawings just so that it will be easy to understand how there are different things. I'll show some documents from our side also. Okay. Sharad, you were asking, can BRF and AH work together? Yes, I was explaining, right? Instead of chilled water piping, there will be an refrigerant piping from the BRF audio that is going to entering into the coil, and from there you are going to remove the heat. Okay, so that is the recent technology where you will have people are coming. With a good thing, and somebody is asking EC fans. EC fans, I can explain. Generally, if you see, Vishnu, can you show a screen fan A2, that EC fan screen?
Yes, sir.
Okay, if you see here, first one, this is called a centrifugal fan. You can see a fan on. There is a pulley. There is a belt behind the fan. There is a motor. So this is going to be a centrifugal fan, belt-driven motors. Okay. On second image, you can see a fan that is called a plug fan. Okay. This is a centrifugal fan. This is going to be in a plug fan. Plug fan, directly the motor is getting mounted. You can see a small circle kind of a coin, right? That is the EC motor which directly put it into the fan. Okay, so this is a front image. This is going to be a back image. From the side, from the center area, it's going to suck and it is going to discharge the area. Okay, but if you see in this two, the orientation fan plays a major role. This fan, if you place in this direction, the air is going to discharge only in front way. Or the fan orientation in the centrifugal fan. If you rotate the 90 degree, that fan is going to discharge only on the top side. But whereas in the EC fan, it can deliver in any direction because suction is going to happen in the center area, and all four side directions it can be discharged because it is going to be placed inside the box. From any side of the box, if you cut the edge part, then the air can be taken out. So that is the EC fan's advantages. Okay. And the power consumption, the speed, the motor speed, if you see here, it is going to be run for 1800 RPM, whereas EC fan that is going to run for 4000 or 3000 RPM, which is going to be a very huge speed, but the power consumption is going to be lesser. Okay, but the speed and the noise is going to be huge in the EC fans. So we have to choose a right fan. You cannot choose just any fans in that EC motor because the right fan, choosing a right fan is going to be in a very tedious situation for us because higher capacity, if you choose a smaller fan that is going to run 4000, 5000 RPM to generate so much of air quality, then that is going to be in a huge. I have an image, just I'm going to share a screen. Can Vishnu, can you stop the screen so that I can share? So I was saying, right, it is, this is the project we have done it. If you see, it is a 15th floor building. So this is going to be in ground floor, retail office.
Sir, we are not able to see that, sir.
Yeah. Yes, yes, sir. I have
Sir, we
shared.
are not able to see your screen, sir.
Okay, okay. I'll reshare it. Is my screen is visible now?
Now
Can
it
you
is
see?
Yeah, now.
Okay, if you see, this is going to be in a building.
No, sir, no, it's not visible, sir.
Why? I don't know. I'm unable to show this CAD drawings.
Otherwise, you can send it to our people, sir. So you can send it to Vishnu so that she can.
Sir, it was visible, sir.
Visible, huh?
Yes, sir.
Then it's okay. Okay, fine. That means my computer, I think there is some.
Okay, now the AutoCAD is visible for you, right?
Yes, sir. Yes, sir.
Okay.
Yeah, yes, sir.
How about others?
Yes, sir. Now it is visible.
Visible, sir.
Okay, done. So if you see, this is going to be in an office space. I was saying that it's going to be in bad space. You can see it is office 1 and office 2, and the center area has been designed for toilet area, lift area, and these are all the shaft. You can see a piping, right? So we have just leaved. This is going to be in a shaft location. You can see different pipings, right? So likewise, we have some 15th floor building. Just imagine 15th floor building. It's a 15, right? Yes, 15th floor building. It's a typical building. Anybody can come and occupy this thing. So we are giving a shaft. This is going to be an HVAC shaft. We have just a shaft piping. We are just laying a pipe. Just imagine how massive it is. This is going to be in a terrace area. Okay, so you can see multiple boxes, right? These are all the VRF units, outdoor units, which is serving for the different floors. Just imagine how the piping has been done. What is the VRF ODU sizings? You can just imagine. Okay, and meanwhile we are supplying the fresh air. The fresh air system has been supplied from the terrace and it is going to take into the space. Okay, so just see the floors. In the 15th floor, you will have huge number of VRF ODUs. From there, the refrigerant piping is taken to the terrace. So this is how we used to design. So I just want, somebody was asking whether the HUs can be combined. Yes, this piping can be taken to the below floor, and even the tenant can decide. He can take a call. Maybe he can place one AH room, and this piping can be taken into this AHU, and he can supply the AHU. He can supply to the entire space. Okay, so that is having a VRF system. But if you see in a chilled water system, I can show some other information. So any other questions? Can HU can be placed near the outlet and it can work as a normal AC without any cooling tower? Your question: can HU can be placed near the outlet and can it work as a normal AC without having any cooling tower? No, your question is I'm unable to. Sir, I'm unable to understand your question, sir. Okay. Okay, I'll just okay. Any other questions so that I can answer? Sorry, guys, I was running, pushing, assuming 9:30 is a thing, so I was pushing for the thing. So,
Rego sir, I have a chiller drawing. I mean, a floor drawing.
Okay.
Can I post it so that you can explain to the viewers?
Okay.
Yeah, I will just present it. Okay. 1 minute. So we will have a short discussion on it. Okay,
yes,
because
sir.
some are very new, I think. Very new. So this is, I think there is a chiller here. I think you can expand this, and I have one more floor drawing like this.
Okay. Okay, sir. So this is going to be in a water cooled chiller, this evaporator and condenser, right? So this is going to be in a 2 tanks. It's going to be in a heat exchanger tank. So I was showing some water cooled images, right? It's we have some 2 cylindrical tanks, right? So one tank is going to be an evaporator, and there will be another tank is going to be in a condenser tank. Okay, so below that there will be a compressors. So in the tank, if you see, there will be a multiple tubes will be running inside these coils. Okay, so in the tube you will see the refrigerant flow within the tube, and it is a kind of on a shell and tube heat exchanger. People, you definitely would have come across shell and tube heat exchanger is nothing but in the tank that is a shell. In the shell there will be huge amount of water will be stored, and in the tube the refrigerant is going to flow from one direction to other direction. So similarly, we in the olden days, if you see, there will be a heater, right? Kind of on a bar kind of thing, where you will just put it into the water. The same concept. There will be heater which will be put in there. Then automatically the heat is getting transferred to the water. The same concept. The refrigerant will flow within the tubes. From the refrigerant, from the tube, the water is getting cooled. Okay. The same way happen. The same condition here. On other direction, the refrigerant heat has been removed from the condenser side, and the water has been taken to that area. Whereas in the evaporator side, the refrigerant chillness has been taken from the tube, and the chilled water has been supplied to the HVAC. So if you see, just imagine this is going to be in a regular refrigeration cycle, but in a VRF system, if you see, the same thing is going to happen, but there won't be any tube or there won't be any water. The refrigerant is directly run from the outdoor unit to the HVACs. Okay, just imagine if I'm going to use such a huge availability of water 1 liter cost is going to be 1 rupee or 10 paise. But if you see the refrigerant, the cost is huge high. Just imagine if somebody punctured in the VRF system, the entire refrigerant is gone. Okay, then we have to add another refrigerant. But in water, it is not that way, because the moment it is getting leaked or something, you can add a water, you can just punch it. But whereas we need a technical skilled people for this VRF system. But in a chilled water system, we don't require. You can just imagine this is how the service schematic. The water is going to, it's all anything is going to be run through the pipe. So there is no connection, there is no direct contact between the refrigerant and the water. It's all just a heat exchanging thing, and water is getting at 6 degrees and entering into the HU. If you can go to next slide, then you can explain. So this is going to be HU. I was saying that 7 degree water is going to enter into the coil, and this H is going to supply the air, and there will be a return diffuser. From the return, it's going to taken into the H room. The moment the HU runs, there will be a supply. There will be a negative pressure in the room. Okay, automatically the negative pressure will suck the air from the return diffuser. This is how this air circulation happens in the HU. And 7 degree water is entering into the room, and the return temperature of 24 degrees Celsius air is going to cross the coil and picks the chilled water is going to pick the heat, and that is 13 degree of air is going to outlet. Just imagine 24 degree air has been directly contact with the coil, and 12 degrees being supplied or 13 degrees being supplied at the diffuser. This 13 degree air is picking the heat. Again, it's going to be in recirculation. You can see the fresh air on the right hand side. There is an ambient fresh air, right? So any people require some fresh air. So the fresh air has been supplied from the ambient condition and entering into the room. So this fresh air is getting heated. Here, the people, we can add one heat recovery valve, so that the return can be directly put into the heat recovery valve. From there, we can remove that thing. Okay, so this is how the regular chilled water schematic. Just imagine top, there is a chilled water. Just assuming this is going to be a top chilled water. Here, bottom it is there. On bottom, if you see, there is a water cooled chiller. From the water cooled chiller, the piping has been raised to the rising. That is called a shaft. People used to call shaft, chilled water shaft. So the chilled water piping is going to raise from ground floor till terrace, and the plant room. I was saying, right, the plant room. This is a water cooled chiller. From there, condenser side, there will be cooling tower. The heat has been removed from the cooling tower. Similarly, the chilled water piping has been directly taken to the HO. This is how the regular chilled water schematic is going to happen. So it is, we prefer any IT related buildings, any 100 TR or any more than 150 TR, it's recommended to go with the chilled water system, because the maintenance is easy, and the operations, maintenance in the sense that technical skilled people are required, highly required for VRF system. The moment it's going to be an issue or it's going to be any maintenance. But whereas in chilled water system, that's not going to happen because any basic issues can be solved as a non-technical person at site level. And the maintenance and the cost for this thing, yes, again, I cannot say you have to go with the water cooled chiller or air cooled chiller or VRF system. Again, we have to run the life cycle cost. Based on the life cycle cost only, we can decide whether it is can be an air cooled system or water cooled system. So any IT related buildings, this is the thing. So I have covered only the high side part of the building. It's all only the chiller, water cooled, because high side plays a major role. Okay, so that is the thing we have designed actually. Okay, so high side part is a major. Whatever the information that we have shown, high side plays a major role. Costing part, entire thing is going to be on the high side only. Okay, so low side, yes, our team Siraj and Vishali, they are going to cover on the low side part, how to do ducting and how to supply the air. Those kind of thing informations can be done in this next program. So the most energy has been consumed and it can be removed, it can be added or can be efficient, can be made in the high side only. In low side, we have very minimal thing, because to have a comfort, we have to have a duct or that cannot be optimized. But high side chilled water system, chiller selection can be optimized. So any system, anything, if you want to cover or if you want to think, you have to choose in the right manner in such a way that life cycle cost plays a major role, and we have to have a different options to work. We have to see different options. Based on the option only we have to use. There are chillers called, and I want to highlight, there are few chillers called magnetic chiller. Magnetic chiller is the latest trend. There are, right, there will be a scroll compressor, reciprocating compressors, likewise screw compressors. Likewise, we have a different compressors are there. But there is a good advantage thing happens in a recent trend. There is called a centrifugal chiller. Centrifugal chiller with magnetic levitation. Magnetic levitation is nothing but, you would have come across trains. Recently, there are trains which will be levitate from the track. Okay. Due to the magnetic field, there will be a repulsion on the train, so it is going to run. So there is no friction or nothing. The same concept has been used here also in a magnetic chiller. The bearing, that is the chiller and the bearing, it is not going to be in contact because it is in a magnetic thing. So due to this different repulsion, the compressor is going to rotate, and it's an oil free. The moment you are going to put an oil, that is going to be in a barrier, or that is going to be in a resistance for that chiller. But in a magnetic, it's going to be an oil free compressors. So the power consumption by the magnetic chiller is going to be less than 0.4 kilowatt per ton. Whereas just imagine air cooled chiller is going to consume 1.2 kilowatt per ton, 1.2 kilowatt per ton. Whereas the magnetic chiller is going to be in a 0.4 kilowatt, sometimes even 0.3 kilowatt per ton also it is going to consume. But anyway, the cooling tower, pumping, other costing is going to be an adder. But the water cooled chillers are very efficient system, again based on the condition. If you see in a Chennai air cooled system and in a Bombay air cooled system, yes, there is a difference. You cannot choose based on the ambient condition. Again, the load we have to see. In Chennai, if you see 40-degree air, whereas if you take it in Bangalore, it's going to be in 36-degree air. So in that 36-degree air cooled is going to perform a very, very, very good manner. So we can choose in a Bangalore, we can choose in a air cooled system. But in Chennai, if we go with the air cooled system, yes, the ambient is going to be higher. Again, by adding an adiabatic kit can be used. The adiabatic kit, it's again depends on the ambient condition. If DBT and WBT difference is very high, then we can use this an adiabatic kit. In Hyderabad, if you see, ambient is going to be 41-degree and dry bulb, DBT is going to be 41-degree and dry bulb is going to be in a 26-degree or 25-degree. So we can directly convert this 41-degree air to the 28 or 30 degrees Celsius. So there you are going to use this air cooled chiller in a good condition. But in a coastal area, if you have the RH is going to be higher, so by default the RH is going to be 31-degree WBT. So it is recommended to go with based on the ambient condition. We have to choose the chillers, air cooled chillers or water cooled chillers that can be decided based on the ambient condition. It's not only a building load profile; it depends on the ambient conditions and various parameters. Even we have to see the chiller spare parts. You cannot just choose a chiller from the foreign chillers or something like that. The moment the compressor fails, how much time it is going to take to replace that compressor, or how much time, delivery time, lead time. So likewise, we have to see, we have various parameters to check on that part. So these are all the chiller system. These are all the different strategy to choose that high side of the IT parks or anything. Can be applicable for regular buildings, not only an IT park building. The same can be done for the regular building, but this is a general practice that we used to have. Thing. So any general questions on this part? In a chiller type system, can we have a different room temperature for different room? Yes, it's a good question, Sharad. Yes, it can be done. I was highlighting, right? HU is going to supply air of 12 degrees Celsius, right? We can vary the room temperature by adding an air quantity or by reducing the air quantity. If I'm going to maintain a 24 degrees Celsius, I require 1000 CFM. This terminology will be covered in the next topic. Say 10 degree, CFM, liter per second, CMH, those terminology will be covered in the next topic. It's again a flow rate unit. So air flow rate, if I'm taking a 24 degrees Celsius in a room, I have to supply 1000 air quantity. With the variable air volume box, that is called VAV box, we can reduce the air quantity by sensing the room temperature. The box is going to partially close, 50% or 60% is going to close. Then the supplied volume will be lesser. Automatically, the temperature from 24 degree can be maintained to 27 degree or 28 degree. Okay. Yes, it is possible. We can have a different thing to have a thing. And one more thing, it means the temperature to have a change in, not in the AHU. AHU, that is the reason we have been fixing the AHU leaving temperature as 13 degree or 12 degrees Celsius. I'm not going to change the thing, but I'm going to play based on the airflow rate. Okay. Again, it is a depending factor. The moment I'm going to stop the AHU or stop the air quantity, that is, I'm going to stop the flow rate, then the return is going to be in complicated. Again, that is going to pass through the AHU. For example, if the room is achieved 24 degree, then the return side will be 24 degree. If I'm going to have a 22 degree or if I'm going to have a 26 degree or something like that, then there is no load. Okay, there is no load. If there is no load, then the chilled water valve is going to be closed. Then the power consumption, both are dependent. It's not only, there are two options are there. One is VFD. VFD will control the variable speed, will control the fan operation, so that the air quantity is being controlled. The same way, the chilled water is being controlled based on the supply temperature of the air. The supply temperature is going to sense, and accordingly the valve is going to allow the chilled water. Okay, so we have to design the valve operation, that is the chilled water. AHU will have some control valve, right? So that is going to allow the water entering into the AHU. So that is going to be operated based on the supplier of the AHUs. Okay, so this is a general strategy, but people are using return air temperature sensors, but it recommended to go with the supplier. Maybe during this session, maybe during that, maybe a next session, I'll take some slide how the AHU's operations are going to be. I can show some screens. Okay, I think I've answered your questions. Any other questions?
So, if there is no questions, any question is there? Further, any question is there? Okay, so if there is no question, on behalf of History Student Chapter of Visual Engineering Colleges, we extend our sincere thanks to Mr.REGOBERT for spending his valuable time sharing his expertise with the students. Okay, so and we are going to have one more session also from Mr.REGOBERT. I think in the afternoon. Sir, thank you for your spending your valuable time with us. Thank you, sir.
Thank you, sir.
Yeah, thank you. Now, Vishnu.
Yes, sir.
You can tell us about the next section. Okay, next session.
Okay, sir.
Yeah.
The next session is going to be on heat load estimation for an IT park, and it's going to be from 10:30 to 12 o'clock. You can use the same meeting link to attend the next session, and it's going to be presented by Ms. Vaishali, who is an HVAC design engineer from Innovel Engineering International Private Limited. Please be 5 minutes before the session so that it will be easy for us to allow and there will be no traffic. Thank you.
Thank you, participants. You can join at 10:30. Okay, 10:30.
Sir, can we close this session, sir? Andrew, sir?
Vishnu, I think you are having two devices. Okay, you switch off one of the device. Hello.
Sir?
I think you have switched on two devices. Okay, it is making sound.
Okay, sir. Can we close the session, sir?
Yeah. No, I think you want to reopen the session after at 10:30. Yeah, is
Yes,
that
sir.
so?
Yes, sir.
Okay. Then it is you open the session at 10:20, or
Okay,
you can
sir.
do one more thing. You can put that slide. I think you have prepared a slide for individual sessions.
Yes, sir.
You can share that slide. Do you have it or not?
Yes, sir. I have, sir.
So then you share that slide and you just leave it as it. You don't close it. Okay.
Okay, sir.
Because yeah.